These are network engineers. They're having performance issues. Things are slow. Things aren't connecting properly. All of the above. And Dan, let me ask you the question. The network engineers would call and call and call and call. And who is getting blamed for slow?
The network is slow.
Yeah, that's what
And
people were.
how often is it the network? Rarely. It does happen, certainly, but I think you would agree that generally we're talking about issues with application behavior or server-side behavior.
Sure, absolutely. And you just mentioned it. Basically, it comes down to is the latency or delay or what is taking the time? Is it the client side? Is it on the network? Do we have a latency issue there? Or do we see it server side or into the application, into the back end? So really the proof or the way that we can quickly isolate it to a silo is in the packets, right? Tools can help, but ultimately, a lot of times tools are just making use of what you're about to see on the wire. So that's why I like going to Wireshark, seeing what's happening on the wire and interpreting, not just looking at lines going across the screen like we see here, and coming down into this area. If I look at my intelligent scroll bar over here to the right, if I come down here, I can hit this patch of black and red and go, oh no, is that my problem, right? That, because it looks ugly. Oh no, I've got a TCP window full. That must be the issue. Oh, look at all these retransmissions. I'm in big trouble, right? But the question is, are those related? Is that really what I'm going to try to troubleshoot? Is that my problem? And that's where packets can help us to answer those questions, specifically because they present the truth, right? Packets don't lie. Well, a lot of times we hear that. Sometimes they do. Those are one-off situations that we'll talk about and maybe in another webinar.
Well,
However,
you just brought up something that I wanted to kind of point out. And I think you will agree with my statement. It's a good idea to proactively and periodically take a look at trace files from normal traffic on your network, because I've seen that behavior happen too. It's like you open the trace file and all of a sudden you're seeing, oh my gosh, I see all of these problems. I didn't know, why am I getting these retransmissions, for example? I better go figure that out. If you don't know what normal is on your network, you're going to go chasing down these symptoms that may have nothing to do with the problem that you're trying to solve.
absolutely. And let me just give you a case in point, Dan, right here. Okay, if you're following along and you have this open in Wireshark, which I hope you do, you might have a little bit different screen layout, color layout. That's what today's webinar is all about, is to get our hands dirty, start to get into the packets and see what we can learn from them. But to Dan's point, we want to know what normal is before abnormal will really jump out to us. One example here on this screen, if you take a look at I have two DNS conversations. All right, so my client, my user is going out to CNN.com. They're just gonna check the news, check whatever. All right, so they send out that first they have to do a DNS lookup, right, to be able to find what the IP is or the layer 3 addressing for that server. If I take a look here, packet 1 goes out, that's DNS to CNN.com. I get a response from DNS 13 milliseconds later, or almost 14 milliseconds later. So to what Dan said, is that normal? Is that good? Is that fast? Well, usually if it takes 1 millisecond, 14 milliseconds isn't happy. Or what if 14 milliseconds is my normal? And then down here, I see another example. Okay, I just jumped up to 70 milliseconds. Now, there's lots of things I should consider. Maybe this is edition.cnn.com. Maybe I haven't looked at that recently and I had to go do some recursive lookups on the back end. That took a little bit longer to resolve. So that added to my additional DNS response time. But the point is right here, if I come down to, let's just take this as an example, DNS. In fact, let's go ahead and set our first filter packet, people. Let's go ahead and filter on DNS. And guess what? That display filter is easy to remember, thankfully. They're actually one that's easy. DNS, okay, good. This is all the DNS traffic that I have in this trace. DNS is an important thing to have, right? I want it to be snappy. I want it to not take too long. So to start off first, I'm just going to assume that many people that are joining us today, we download Wireshark, we install it, but sometimes we need to adjust certain columns to be able to do some of these measurements that I'm doing. So I'm just going to talk to you just quickly about some of the configuration changes we can make. First of all, I want to make sure that everyone has the same time. Now here on the time column, this is my running total of time that I have here. Okay, so from packet 1, start a stopwatch, and as each packet comes in, I'm measuring the timestamps here, and as I go forward, I can see the final DNS packet in this trace came 1.253 seconds after start of capture. All right, the way that I adjust that is I can come up to my view menu. I'm gonna come down to time display format, and I just wanna make sure I have seconds since beginning of capture. Let's make sure that everyone has that configured there. View, time display format, seconds since beginning. Now this is nice because we can adjust this. We can make this time of day. We can say year, day of year, time of day. We can say UTC. We can do a bunch of different settings here. But let's just go ahead and keep it at beginning of capture. Next thing I need everybody to do is we're going to configure a delta time column. What's delta time? That's the amount of time from one packet. This tells me this packet came in 14 milliseconds after the first one. All right, so, and it's within context to the display filter. So here at packet 25, for example, this came in 231 milliseconds after packet 12. So I want everybody to have this. So how do we set this up? Well, let's go ahead and go up to, if you're on a Linux or Windows system, you're gonna go to Edit. Since I'm on a Mac system, I'm gonna go to Wireshark, Preferences. You'll find Preferences under the Edit menu. Okay, so we're gonna come up to Edit, and it'll be down here somewhere, Preferences. I'm on a Mac system, I wanna go to Wireshark Preferences. All right, so I got my preferences up here. We're gonna go to Columns, and what we're gonna do is we're gonna add a column, we're gonna call it Delta, and we're going to select the type is going to be delta time displayed. So add one, name it delta, select the delta time displayed for the type of information that we want to show. And then once you've got that, you can go ahead and drag this column up and you can tuck it next to time. And now you're going to have that as a column that will be shown for this profile. Okay, so hopefully everybody was able to do that. So now I've got running total time. I could also change that to time of day or whatever I'd like. But delta time is always something that I have there. Delta time is super important to me, Dan. I'm always using it. And the reason is with just a glance, I can come over here and I can go, oh, DNS request, reply came in 13 milliseconds later. Now Wireshark even helps us here. It comes over and you see our little arrows over here on the left? That shows me this request went with this reply. So let's try something here. All right, so if I pick packet 11, request, packet 12, this was the reply for packet 11. So if I have a lot of different DNS requests go out, I can match the reply to the request that went out. How about this one? Let's click on packet 25. You notice the response, what packet was actually a part of the response? Here we got packet 28. So they don't always butt up together. Sometimes I have a couple of requests go out. I don't see the response come back until a little bit later. In fact, notice this one. Okay, packet 26. I do a request to this i.cdn, so I'm looking at it for a content delivery network.turner.com. And notice here, my request goes out and it's a little bit before I get that response, over 100 milliseconds. So there's a really cool feature of Wireshark I'd like to show everybody. And if we come down to the response, let's have everybody jump to packet 107. And what I'd like you to do, let's go ahead and expand DNS. And we're going to come down to, you should see this if you're running a version of Wireshark that's north of 3.0.0. Really, if you have any of the threes, then you should see exactly the same thing. If you're still down in the version 1s and 2s, update to 3. So if I select packet 107 and I come down here to time, check that out. That shows me if I select this time measurement, if I come down here to the lower left, I can see, you notice it says dns.time down here. So this is whenever you see those hard brackets in Wireshark that are around a measurement, that is a Wireshark thing. It's a Wireshark measurement. So basically Wireshark is doing us a solid. It's saying, hey, Chris, this response came in 126 milliseconds after the request went out. Heads up, maybe you should look at that.
Hey, Chris,
Cool.
While we're
Yeah,
talking about time, there is a question that I want to get to,
sure.
and related to the conversation we had at the start about when using a laptop and Wireshark is time stamping packets as they come in. The question is, when does Wireshark do the time stamp the frame? Is it after the last frame is CRC checked? It's coming to the
Y-
buffer, CRC checked, and then does it do it? How does that work? Do you know?
Yeah, upon complete receipt, you'll get a timestamp.
Okay.
And it's the packet driver that's underneath Wireshark. So Wireshark is the user interface that is opening the PCAP, but the actual driver that Wireshark uses to capture is either dump cap or npcap, libpcap, depending on our system. It just calls that driver. The driver does all of the actual packet handling, and it says, here you go, here's some stuff that you can read, just like a file.
Is it only
So
going to capture valid frames?
yes, so if the NIC card brings it in, the PCAP driver can grab it and then stamp it and bring it in. However, if the NIC senses, for example, an FCS error, this is where some of the tools that we've worked with in the presently and in the past, having a hardware-based analyzer that can grab packets that are bad, frames that are bad, that have bad checksums. A lot of times you need hardware in front of that NIC in order to be able to bring in even bad frames.
Right. So there's
Because
another reason why your laptop is not going to show you some certain things that are happening on the wire.
for sure, absolutely, and especially that's true in the wireless space, right? So I'm doing best effort, especially if I'm ever capturing wireless. I really want to think about, am I really able to capture management and control traffic, or is it just what this NIC brings in after all of the wireless stuff happens, right? So that was a good question. That was a great question. I'm do I say victim of circumstance behind the NIC card? My window into the network is based on what the NIC card will bring in. Promiscuous mode helps because when we install Wireshark and we capture, we want to capture traffic that is not just to and from ourselves. We want to capture if we're on a span or a tap. I want to be able to capture your traffic, Dan, anyone else's traffic on the network, not just my own. Promiscuous mode helps me with that. But even promiscuous mode won't let you capture errors or in a Wi-Fi environment, depending on your hardware, things like management and control traffic. All right, so what do you think? Should we do a little something with this DNS.time thing?
Sounds fun. Let's go.
Sound like a good time? All right, let's have everybody do this. I'm gonna go ahead and right click this. Now I'm gonna show you one of the things that's tough about Wireshark. Hey, I live in this product and I still have a tough time memorizing all of the filter syntax. Oh, it's hard, right? Was it IP.add or was it TCP.port? Like what? TCP.flags. Whatever. What is it that I need to do? The cool thing about Wireshark is you got a little cheat sheet that's always there for you. Anytime you click on anything in any packet, that field is filterable basically. So anytime you click on a field, notice down here, watch. If I want to say, okay, for example, queries, I want to filter for this name. So right now it's telling me, okay, dns.query.name, that's that field. And now I just got to give it a value in that field that I want to filter for, right? So even down here, this time measurement, this is dns.time. So what that means, I can right click this and I can come up, prepare as filter selected. Let's all do that. Now it's going to take and cut and paste this and put it upstairs. In fact, I can even, if I want to, I can even take that field and I can be real fancy. I'm clicking and dragging right now. I clicked it. I'm just going to drag it and drop it up to the
Oh, it's a miracle.
far up above. Kind of cool, right? So I can throw a filter upstairs and apply it immediately. And I did that just by clicking and dragging. Now, this is great. I got one packet that the DNS time equals 126 milliseconds. Fantastic. Okay. I want to instead build a filter that will show me any DNS call that is greater than, let's pick a number, Dan. How about 50 milliseconds? Okay. So I'm just going to back this out and I'm going to say 0.05, that's right. There's my mystery 0 there, so 50 milliseconds, I don't really need to have that. And I don't want just DNS time equals that value. I want to know anytime DNS time is greater than 50. So that'd be kind of a cool thing to know. So this is showing me all DNS responses that took longer than 50 milliseconds to hear back from. Now, in our purposes here, 50 milliseconds, that's still pretty quick, right? I might not be super worried about 126 milliseconds unless it constantly happened a lot. One slowish kind of thing like this, 126 milliseconds, isn't going to kill me. If I see this 100 times, that's where I start to actually experience real latency, right? That turns into screen punching, human frustrating delay. But with a filter like this, check this out, everybody. Now we can go, okay, so you see our little filter bar up here. If I come over here to our plus button, now what I can do is I can add that filter as a saved filter that I can quickly access later. So let's have everybody do that. Just go slow DNS. And our filter syntax is DNS.time, anything that is lower or greater than 50 milliseconds. And if I say okay, now check us out. I've now got a button on the top right that says slow DNS. I no longer ever in my life have to remember that syntax or remember how to do that. I just come up and I click that button, boom. Now I've got all my slow DNS responses. So that's a trick that I want everybody to know about. You can save filters. Also, Wireshark does a lot of measurements like the one that we see there, DNS.time, that we can use to find slow. I'm going to show you a couple more before our webinar is done. But I'm going to pause just for either comment or question. How are we feeling, Dan?
We're doing good.
All right. And if anybody does have any questions about what you see, feel free to pop it on the chat or the Q&A area of the webinar. We're happy to answer those questions as we can. All right. Dan, is DNS always the problem?
I'm going to guess no.
All right, you're right.
It's common,
Yeah, there we go.
but it's not always the problem.
Yeah, that's a good man. It's not always the problem. In fact, well, nothing's always the problem. Anybody who says that is selling you something, right? So sometimes DNS, that's something that we want to be aware of. We want to make sure that we're getting a healthy, quick DNS response. And we can go down a long DNS rabbit hole there. But let's back up a moment. Let's just take a look at this first DNS response. Let's go ahead and remove our filter. We're going to jump up to the top again. All right, DNS looked good. So what happens after we get a successful DNS response? Well, we turn around and we're going to issue a TCP SYN. So we got the address of the server that we want to talk to. Now we're going to actually do a layer 4 TCP SYN to it. So now let's do some measurements within TCP and also get a little bit into this application and see where time is falling. All right, so here's our first SYN. Now, as we know, that's the very first packet of a three-way handshake, which consists of the SYN, SYNAC, and the NAC. Now notice right after the SYN, I have this ARP that goes out. Okay, so I SYN, and then right after that, the next packet I see is this ARP. Well, who's sending this ARP? It looks like .1. Now, .1 is ARPing for 145. If we take a look at the addresses up here, we can see 145. Well, that's me, that's the client. So it looks like the gateway, let's just for now assume, okay, there's our gateway, and he is saying, hey, I'm looking for 145. Who's out there that has that IP? I come back and I say, oh, here's my MAC address. And then let's take a look at the SYNAC. Let's look at layer 2. Okay, so our .1 box, we know that this is .1 because if we just do DC39ED, that matches who sent that original ARP query, DC39ED. So .1 was the one that was sending this. That's our gateway. So he's saying, okay, here you go. Here's your destination MAC address. You just told me what that was, Mr. Client. Okay, great. The ARP resolved, and then we were able to get this SYNAC. So looks like what happened, we sent our SYN out. SYN traveled to the server, server responded with SYN-ACK, SYN-ACK arrived at the router, for whatever reason, maybe it's ARP cache timed out, maybe it didn't want to trust its ARP cache, maybe this is a part of the way that that router was like, first verify, make sure your ARP's good, okay, good, so let's go ahead and send this out to the end user. Either way, we saw that ARP, it happened quickly, we resolved it quickly, and then we were able to get that SYN-ACK back from the server. Now, let's take a look at a couple other things.
Hey, Chris, before you move on,
Sure.
I want to go back to the filter questions about filters. Got a couple of them here. One, how do you delete saved filters?
Ooh. Mm-hmm.
That's one.
Okay, so first of all, let me just do that by coming up to preferences.
Okay.
And then if you go to, again, for me, this was under Wireshark, and for Linux, Windows users, you're going to find it under Edit, Filter buttons. Then you have
Oh,
all
you
your
can turn
filter
them on and
buttons.
off.
So now I can take that DNS one and go, I don't like that one. I'm just going to either delete it or I can uncheck it and it'll be hidden.
Gotcha. So you can save them, but not display them in that top bar.
Correct.
Got it.
That said, while we're here, everybody, if I can add just another little
do it.
fun tip. Notice that I also have all these little ones where I have these double slashes.
I do.
So I use a lot of saved filters, as you can see. Just in this profile, I have the ones that you see here. And if anybody's interested, they can send me a message on Twitter or whatever, email, and I'll gladly share this profile with you. But basically what started to happen to me is my top right got really busy with all of my different display filters. So what I started to do was nest them.
Oh, look at that.
So TCP connect, here's all my filters for TCP stuff. So bad TCP, TCP resets, low receive windows, SYNs, full handshake. Slow stuff, here's slow TCP, HTTP, slow delta, slow DNS, broadcast stuff, right? So the way that you nest is that if you come into your preferences, I'm gonna go to filter buttons, you actually have to put the top level, whatever you're gonna call it there. So I just said TCP, for me, it's connect, and then just do your // and then you can have your filter number.
Got it. You mentioned there was another question about will filters be saved during an upgrade? I lose them often. It sounds like the filters are associated with a profile, and profiles sounds like can be exported and
Yes.
saved and reloaded. And that would be a way to ensure that your filters are saved when you upgrade and or want to pass them like you're going to do to other people.
Yes, the only time I gotta be honest with the audience, I've never lost my filters from an upgrade. I upgrade all the time. I think the only time was when I went from like version 1 to 2 dot something, when it was a bigger jump. But it's been a while since I've lost filters because of an upgrade. And the reason is because if you look down here into this little blue link that we have here, I know it's small on my screen, but people can see it on theirs, hopefully. And in preferences, this tells me where these filter buttons are saved, right? So this is actually, it's a hidden folder, right? So this is .config, Wireshark profiles, TCP plane, that's the name of the profile that I'm using here. You can see that in my lower right. TCP plane, and then these are my display filter buttons. So this does not get overwritten when you do an upgrade, typically. So if you are losing them, that could be something else. Like maybe there's something else going on there. And definitely reach out to me, or you can go to ask.wireshark.org. That's another place to get some support. Ask.wireshark.org. That's a good spot for a question like that.
And here's another tip from one of our listeners. It sounds like when you right-click on your filter names in the top bar, you can remove or disable from that place directly, sounds like.
Thank you. Yep, that's another place to do it. We can right-click and come up here. We can just remove it, edit, disable it. Actually, that's a newer, thank you to the viewer who mentioned that. That's actually a newer thing that was added. So I'm still in my old habit ways of going over to preferences, but yeah, so there we go.
Cool.
Now, you did mention, Dan, as well, profiles. I just want to let the audience know as well. So you can save a collection of saved filters like we do here. Those are all saved to what I call my TCP plain profile. And that saves coloring rules. It saves filters like we have here. Maybe if there's certain protocols that I don't work with a lot, I can disable those dissectors even, so I don't have to wait longer for a PCAP to load. So things like that can all be saved in basically a group of settings that's called a profile. So depending on if I'm working with, say, for example, you can see some of the ones I have here, Quick. If I'm working with the Quick protocol, well, that's not TCP based. So I have a whole bunch of different filters that are specific to Quick. How about my cybersecurity profile? I'm looking in security. I want to have my time be time of day. I don't care about Delta time right now. I want to see port numbers. That's more important. Time to live, the TTL and the IP header. I want to take a look at all my signatures, look at inbound connections, weird HTTP versions, all these different filters that I can save that are nice in that profile. But Dan, I don't need that all the time. So sometimes I just want to come down to back to my TCP plain profile. Or how about, Dan, you send me a PCAP and it's slow across a local area network. We're having a slow file transfer. Okay, so maybe my head goes, ooh, I might have some TCP protocol things going on. Let me check my Windows. That's where I could go to TCP Windows or TCP Advanced. I have another profile for that. Let me actually make this a little smaller here. So I have a lot of different columns and things that I can add and remove, and I could save these into profiles, or I can just use my working profile. This is just my getting started when I'm first opening up a PCAP, and then I can have other places that I can go depending on protocol or function or what I'm trying to troubleshoot. Hopefully that was helpful, a tip for people.
You bet.
Any other questions? How we doing?
We're doing good.
All right. How about we set a TCP filter? Because right now we got DNS, that looked okay. 14 milliseconds, big whoop. All right. I want to set a filter for this TCP conversation. Now, something that I do in my profile here is I like to paint my sins bright green, and anybody who's seen any of my videos has seen that. For me, I like it because they jump out. If you take a look over here at the intelligent scroll bar right away, you see all these little bright green lines. I know that those are all TCP sins. Those are new connections that are being established. So for me, I like that. I'm going to show you how to do it. Let's go ahead and select the first packet. And what we're going to do, let's go ahead and actually just set a filter on this conversation. I'm going to do right click. Now this is where I'm going to just give people a hand slap if you come down here to follow. Follow is nice. You can do follow TCP stream. I see a lot of people go, oh, right click a TCP packet, follow TCP stream, follow TCP stream, follow TCP stream. That's not in itself wrong to do it that way, but this is what happens. If I bring up a TCP stream, then it's going to extract the data from that TCP stream and put it on this screen. And this does give me a way to be able to look at the application level traffic that was happening. I can look at the cookies and all that kind of stuff. But for me, usually what I end up doing here, unless I'm specifically looking for a type of code or something in the application itself, I'm troubleshooting TCP, all I do is come over here and say close. And then I'm back to my packets. Well, a faster way to do that, and something I'd like everybody to get more used to, if you will, let me just remove my filter. And I'm going to come back to packet 3. I'd like you guys to right click and go conversation filter TCP. Why? Well, technically what we're doing is really we're going to get to the same packets, if you will, but now I don't have that stream data that's extracted. If my goal is just to set a filter for a TCP conversation, well, let's do that. Let's right click it, TCP conversation, and then we just get those associated packets. Now, alternatively, Dan, we could have typed in this nice, long, scary looking syntax to filter for this, but do you feel like memorizing stuff like that?
Not today, I don't.
I didn't either. That's why we just right click, it's a little easier, right? Or to simplify it, sometimes what I'll do this is like a life hack for us. If we have a problem with right clicking, Well, something else we can do is we can just filter on the client side ephemeral port. You see this high number ephemeral port? A lot of times, not always, but a lot of times that is unique in the trace file because it's a dynamic port that the client picks to then be able to establish this connection. All right, so we've set our filter. We're just taking a look at this single TCP conversation. Now let's take a look at our handshakes. A SYN, SYN-ACK, ACK. All right. Now, first let's paint these green because that's fun. So I'm going to select packet 3. And what I want to do is I want to come down to the TCP header and then notice flags. Wireshark's kind of doing this for me. It's just highlighting all this stuff for me. And it's saying, hey, SYN, the SYN bit is true in this packet. All right, so TCP.flags.syn is the location. And when that equals 1, that's a SYN. I see it there, and I also see it in the SYN-ACK. All right, so it's also SYN. But in the SYN-ACK, obviously, I see the SYN and the ACK bit set. So what I want to do is I want to set a filter, basically. I want to identify all packets that have the SYN bit set. That's how I can then choose to color those. All right, so what I'm going to do, I'm just going to test this out, Dan. I'm going to come up here to the top. TCP.flags.syn, just to get some practice, equals 1. This is going to show me all the SYNs in the trace file. So now what I can do is I can just either remember or copy that. And what I'm going to do is go up to View, going to come down to Coloring Rules. Now, part of this profile, here's some coloring rules that I have, some simple ones. Just going to add one, new coloring rule. I already have this one, but I'm going to show people how to do it. TCP SYN, filter. The filter that we're going to use as the basis to set that coloring rule is going to be tcp.flags.syn equals 1. Anytime you see a 1 in the SYN bit, color it. What color? Let's select that line there, and we're going to go to background. And this is where we get to pick our color. We want to do bright pink? Sure. Let's color all those SYNs bright pink. If that's what you want to do, choice is yours. All we got to do is activate that coloring rule, and then I like to take it and drag it underneath bad TCP. And the reason, if I ever have a SYN that is a retransmission, I'd rather have that retransmission show up as the bad TCP colors. So black line, red letters, scary looking retransmission, rather than the color that I've chosen for the SYN.
Oh, so there's a hierarchy here.
Yeah, this is an order of priority. So if I have a packet that matches more than one coloring rule, the higher priority will be the king. So if I say, for example, Dan, I connect to you and I try port 57, I'm just picking one, and I send a SYN to port 57. If I have to retransmit that port, if I have to send a retransmission and I'm using the same sequence numbers and everything, then I want the first SYN to be green. That was the first attempt. But if I have any retransmissions, I don't want those to be bright green. I want them to be black and red. So that's why I'll drag that below and I'll keep the bad TCP up top.
Brilliant.
All right, so we're gonna say okay. Now we hopefully have green. If you do not have green, you come up here to the top. You see this little reload PCAP button. Hit that a couple times and you should hopefully see your SYNs turn whatever color you selected. And now they'll jump out at you a little more when we're over here on the intelligent scroll bar. Now, I'm going to show everybody a little trick here. Something I can do, if I select this packet, packet 3, I can come up here to, it sees pound TCP stream. And what that does, that is a button, and I'm going to put this filter in our chat down here so everybody can take a look at it. All right, so what this means is it's basically, it's an advanced filter that says the TCP stream will equal the value of the stream of the packet that I'm presently on. So what that means is you pick a packet. If you ever pick a TCP packet and you just quickly want to say, okay, I'm just somewhere in my trace file, I'm randomly picking packet 145. I want to filter on just that. I can come up here and I can just say TCP stream filter, and it just boom, sets a filter. I don't have to do right click. I don't have to type anything in. It grabs a conversation filter or a stream filter for just that stream without bringing up that stream data. So I just threw that in the chat for everybody, and you can save that as a filter. All right. So before we start to do our wrap up and more questions, I just want to come back up to packet 3, conversation filter TCP, just to get the practice. Now, something that my eyes do, Dan, quite a bit when I'm looking through PCAPs, looking at TCP conversations, is I want to know my handshake round trip time. My IR, we call it IRTT, initial round trip time. How much time did it take for me to get to that server, for the server to send a SYN-ACK, and then me to send that final ACK? What was my handshake establishment time? That's a big deal, because now that shows me my initial benchmark getting started, coming out the gate, round trip latency. If I ever see this shift throughout the life of the conversation, well, then I know that the network is having induced latency. Or if this is taking, I just saw this morning, I was troubleshooting a problem for one of my clients, and we were having like 600 millisecond handshakes for a
Jeez.
device that wasn't that far away. So I said, why are we getting 600 millisecond handshakes for a device that's only 10 hops away? And the user's like, I don't know. We got to find out what's inducing our latency here. It is the network, right? Or maybe. So this is a big number for me. So what I'd like everybody to get used to is when you're looking at a handshake, just look at that delta time. That tells you your network round trip between you and that device. This is also a number that we can filter for. If we come down to packet number 7, and I'd like to take a look, let's peek down to the TCP header. And if we scroll down, we can go into sequence analysis. And you see very bottom down here. Let's have everybody go down and find it. This is the IRTT, initial round trip time. This value is something Wireshark calculates for us. It's also a number that we can filter for. You see down here on the bottom left, tcp.analysis.initial_RTT. And you bet we can take this value, right click, come up here, prepare as filter, and I can say, let's go ahead and prepare a selected filter. Let's put this upstairs. So now tcp.analysis.initial_RTT, this is 74 milliseconds. Well, now I can start to play with this value. I want to know, do I ever have a handshake that takes longer than 100 milliseconds? I can just add 0.1. And I do the same thing as I did with DNS time. I just do my little greater than. So now I have, go ahead and show me any connection in this entire trace where the handshake took longer than 100 milliseconds. So now I've got 53 packets that met that, and I can start to go hunting and see if I see any patterns. Do I see certain servers at a higher latency? What on earth am I doing going to this device here? I should be going to a different data center. I thought we relocated that to a different cloud, or why are we, right? So that starts to be a pretty useful filter as well. Gonna pause for comments or questions.
Hey, back on the color rules. Question is, many of us wireless people use MetaGeek color rules for wireless analysis. Is it possible to make a wired color palette to be used for wired profiles and another one for wireless profiles?
Absolutely. When you switch over to your wireless profile, those coloring rules will come with you.
So they apply to the profile.
Yeah, like you can see here, like in the wireless profile, my SYNs aren't green.
Uh-huh.
You see how they're not bright green. And now if my scroll bar, they disappeared on me. So because in wireless, a lot of times I'm not looking for, if I am looking for TCP, usually I flip back to TCP, but if it's just Wi-Fi, then I have different filters and different columns.
Cool.
Good question. Algo más? Anybody else have any questions?
Nope, good.
All right, so we're gonna.
I know everybody would probably like to stay online for hours listening and watching you, Chris, but we are coming close to the top of the hour. So just as a heads up, one more. Let's do one more.
Okay, great. All right, I got one more to show everybody. Okay, I showed you about DNS latency. I showed you how to find handshake latency, but we also can take a look at application response time, or basically HTTP latency. So, okay, let's go ahead and go back up to the top. Let's go back to that original handshake that we had. Okay, so we're gonna go to conversation filter, TCP. All right, so handshake goes, sin synac hack. And by the way, just to bait people to come on over to my channel, I talk about all kind of stuff on the channel. So if you've ever wondered about these options down here, what is maximum segment size? What is a window scale? How does SAC work? What is a dupe-back? Actually, just this morning, Dan, I posted a dupe-back video on my YouTube channel all about when you see dupe-backs, when do you have to worry? Why do they occur? Why do I see thousands of them? And yeah, what's the deal? So go ahead and check that out. I really break down and dissect the handshake to its very bits. But for the purposes of our time, we have a good connection. We saw Synac come back. Now that we have the TCP road that has been paved and both sides have agreed on certain options here, which we don't have time to talk about right now, come back next week. We're going to be talking a bit more. Next, we do a get. So this is our application is saying, okay, this is what we wanted to do the whole time. I wanted to just send a get to a server. But before I could do that, I first had to do resolve DNS, and then I saw ARP, and then I saw TCP do its handshake thing, and now, okay, I can do get. Now, thankfully, this is open. This is not a TLS connection, because we would have yet another handshake to have to go through with TLS handshake, and then we could send a get that's encrypted over that TLS connection. This is still open web that we're dealing with because it's just easier to learn. So we send a get to the server, and notice this, 78 milliseconds later, I get an ACK from the server. Okay, 78 milliseconds. So what I do, almost muscle memory, I say 78 milliseconds, awesome. I come up here and I compare that visually to my initial network round trip time. 78 milliseconds, 74, 78, 74. I'm only a few off. I'm pretty happy with that network round trip time. But what if, Dan, I saw 74 up here, but this ACK to this get took 500 milliseconds? And
What
like,
if?
whoa, ugh, gross, right? That's a dramatic change from the initial connection setup, right? So that's something that I might want to look at. In this case, it was all right. So our ACK came back, and right on its heels, 3 milliseconds later, I actually got the 427 bytes coming back from the server. Now, this is another little thing that's different about this profile. I'm actually looking at payload length, TCP segment length. I went over here and I said TCP segment length, right click, add as a column. What that does is it shows me the payload, the amount of data in the payload rather than the whole frame length. I don't always care about the amount of Ethernet and IP and TCP header bytes. Don't show me that value. I just want to see what actually is carrying things. And that's why I have TCP segment and not frame length. So that's where you can add that, everybody. But this is an actual response coming back from the server. This is real stuff. This is an application response. Well, if I look over here to the left, you can see with frame number, I got 2 arrows. Request, response, request, response. Well, that's pretty cool. Well, guess what? If I collapse TCP and I expand HTTP, I can come down here. There's a value in here that says time since request. Wireshark does that for me. It goes, here's an HTTP response. I'm going to marry that to the request, and I'm going to give you the delta time between the two. So now I know the total amount of time to get that response was 81 milliseconds. Sure enough, I can right click. I can say prepare as filter, selected. I can say, you know what, show me 0.05. This is just a number I'm picking. Now I have an HTTP time filter. Show me any responses in the entire trace file that take longer than 500 milliseconds or 200 milliseconds or 100 milliseconds. Now I can see all of my slow HTTP response times to open web servers. I think that's all that I get to talk about today, Dan.
We are coming up to the top of the hour, but I tell you know what? Got a very good question here from someone named Joe. And I think maybe a lot of people are thinking this. I'm kind of thinking this as I'm watching you. Your expertise is evident, Chris, but here's the question. Are there any tips for those who might be feeling overwhelmed when trying to learn and understand Wireshark? I mean,
Yes.
obviously you've been, like you said, you're in this all day, every day. This is your job, being a packet head. Um, Most engineers that I've come across know how important it is to have this skill, but gosh, you just got so much other things going on. What kind of tips would you give to people about how to improve their expertise and not feel like, oh my God, I'll never learn this?
First of all, I get you 100%. I understand what it's like to be new and look at all these buttons and flying around this analyzer. Part of the reason why I fly around it quickly is so later on we can always pause and follow me, and that kind of stuff. There's lots of information out there. First of all, stop by my YouTube channel. I have a series on brand new Wireshark users. It's called a Wireshark Masterclass. And maybe, Dan, I saw that you linked the channel. If you
Yep.
go out there and you look at, I literally have a 10 video series on brand new to Wireshark. Here's a trace file. Let's learn how to configure it, how to look at packets and protocols, how to set a few basic filters. Basically, it's taking a lot of what I just showed you here in a 1 hour period of time and just stretching it out over a mini course. Okay, that'll get you started. After that, I also have courses that I teach live. In fact, I have one coming up this month. It's January 25th, 26th, and it's going to be a 2-day full course on how to use Wireshark and get into the weeds of troubleshooting. There is absolutely no substitute for doing it yourself. Okay, so you guys just watch me do it for an hour. Do it yourself. I think I learned a lot. I can't say most, but I learned a lot just by capturing traffic going to and from my machine during calm periods. The
Yeah.
fireman doesn't learn how to fight the fire while the building's ablaze,
Yeah,
right?
I was just thinking about that analogy. We talk about that a lot.
Yeah, you go out to the parking lot, you learn how to, the angle of the hose, the pressure, like what happens and it blows you backward off your feet. Like you don't want to wait until there's a burning fire and you've been breached and all of your company secrets are gone to some who knows place and here's the PCAP. It's like, no. So check out the YouTube channel. If you'd like a more in-depth training, stop on my website. That's absolutely something that I offer. But literally, there's no substitute for capturing for yourself and just slowly walking through each packet.
Just play with it.
Yep, slowly walk through. Keep in touch with me. Ask questions. Reach out. I'm happy to help you. If you have a question about a certain protocol or a behavior, um, I'm doing everything I can to make as much free content out there. If you just want to take a free course, you can actually, in several of my videos, there's a link to some of my Pluralsight content that you can watch on demand, and you can even have a free trial of it. So yeah, that's how I would answer that question, Dan.
You bet. Hey, last question that came in. There was a question about LinkRunner G2, another part of our product line. LinkRunner G2 is a 1 gig instrument. It does do line rate capture, but it is limited to 1 gig. So if you want to do packet capture with LinkRunner G2, you can do much of that here. The one aspect that LinkRunner G2 does not do, we've had a little side conversation going on this here. One was around testing or capturing bandwidth between sites. We have a particular function in LinkRunner 10G and EtherScope is the network performance app, which generates test traffic, sends it across the network at your desired rate up to line rate, so you can characterize bandwidth from site to site. The LinkRunner G2 does not have that particular capability. There you need to be in the LinkRunner 10G or EtherScope. Hey, Chris, I'm always amazed. You've done such a great job on this webinar, and like I said, your expertise is really evident. You make it look easy, and I really appreciate particularly your answer to that question about how this might look overwhelming to folks. And you do consulting too. So if people are having problems, they just can't get to the root cause, they can contact you. You're open to consulting gigs too, and so people can look you up for that as well.
For
Thank you
sure.
very much for your time today. Everyone, thank you so much for joining us.